its core, the immense pressure and temperatures produce a staggering 15 million degrees Celsius. Here, sunlight is produced, and after bouncing around the solar interior for up to 200,000 years, it finally reaches the surface to be released into space. At the surface, the sun is a lot cooler but still incredibly hot. It's still around 5,500 degrees or so. Yet here, on the surface of the sun, we have found water. Not in a liquid state, but in the form of steam. More specifically, this water has been found in these darker, slightly cooler regions called sunspots. You know, when a spacecraft takes off and a huge cloud of smoke is formed, usually covering the entire launch site, this is actually not smoke. Well, some of it is, but most of it is actually steam from the pool of water underneath the spacecraft. The water is used to absorb some of the acoustic shock waves created during takeoff that could potentially bounce off the platform and basically shake the spacecraft apart. There's a mysterious phenomenon called long-delayed echoes. If you're in a large empty room, it's likely that sound will reflect off the surroundings and produce an echo. Radio signals kind of work the same way. So for example, radio waves that hit the moon bounce back towards the Earth and produce an echo 2.7 seconds later. Now the strange thing is, people have sent radio signals into space and heard echoes up to 40 seconds later. If it were an object in space, it would be way beyond the moon. Right now, no one really knows what's causing the echoes, but the most likely theory is that the signal somehow gets trapped in the atmosphere before bouncing back towards the Earth. Or you know, it could be some bored aliens playing space pong with us. One of the two. On the morning of September 1st, 1859, astronomer Richard Carrington was observing the sun and noticed a cluster of enormous sunspots. After a while, Carrington spotted a sudden explosion of light erupting out of the sunspots. What he saw was something that is now referred to as a coronal mass ejection, or CME for short. The most devastating effect of these solar superstorms is that they can wipe out anything electronic. The Earth is basically bombarded with EMPs. Luckily for us, society's electrical framework was in its infancy at the time, and thus we didn't really experience any significant damage. Still, the event was powerful enough that it caused telegraphs to actually catch fire, while auroras could be seen across the globe. Imagine if an event like this struck the Earth today, at a time when everything and everyone so heavily depend on electricity. If the storm is strong enough, it could cause an apocalyptic event, taking years or even decades to recover from. What's even scarier is that in 2012, this almost happened. A CME equal to or possibly even stronger than the Carrington event went straight through Earth's orbit. Luckily, Earth wasn't there this time. It's always hard to imagine the vastness of space. Take the moon for example, because it's something we can actually see with the naked eye. It feels like it's not that far away. I mean, we know it is, but we just don't have anything to actually compare that distance to. But if I put it like this, between the Earth and the Moon, we can fit not one, not two, not three, but all 8 planets in the solar system side by side with a few thousand kilometers to spare. And that's just between us and the freaking Moon. The distances between the planets and beyond is just inconceivable. This is one of those facts where even I, as I'm reading this, have a hard time believing it's actually real. Another thing that speaks for the vastness, or maybe I should say the emptiness of space, is the fact that the Sun contains 99.85% of the total matter in our solar system. That leaves us with the insignificantly small amount of 0.135% for all the planets including Earth. And that's just in our solar system. On a galactic scale, let's just say there would be a lot of zeros. NASA has its very own radio station called Third Rock Radio. Get it? Third Rock? Anyway, on this channel they play rock and alternative music along with space news and NASA mission updates throughout. Rocket launches that take place between 30 to 60 minutes before sunrise or after sunset produce a beautifully colorful effect called the twilight phenomenon. Basically, when the spacecraft rises out of the darkness and into the sunlit area of the still rising or setting sun, water left in the vapor trail of the launch vehicle reacts with a less dense upper atmosphere. The exhaust plume, which is suspended against the backdrop of the dark night sky behind it, is then illuminated by the sun. When we look at things in space, almost everything appears to be round. Large bodies are sphere-shaped, orbits are circular or elliptical, even solar systems and entire galaxies are spinning around and for the most part take the shape of a disk. Then there's Saturn. Saturn's north pole is quite bizarre as it goes against the natural roundness of the universe and takes the shape of a hexagon. The strange cloud pattern was first discovered in 1981, and while some theories exist, it remains unexplained. And it's possible that Jupiter have similar shapes, but as we've never actually taken a good photo of Jupiter's poles, we just don't know yet. Maybe when the spacecraft Juno arrives in 2016, this mystery can be solved. Lastly, I just want to show you something, a simple image of the Andromeda Galaxy. We've all probably seen an image or a photo of it before, after all it's the closest spiral galaxy to our own. It was even the default background on Apple's OS X line, so millions have definitely seen it. Nevertheless, this is not just a common photo. At 69,536 by 22,230 pixels, or 1.5 billion pixels in total, this 4.3 GB file is the largest photo of the Andromeda Galaxy ever taken. And it reveals something we have known all along, but it's really something else when you actually get to see it for yourself. As we come closer, it almost looks like there's an extreme amount of grain. But as we advance, individual dots emerge from the chaos, and we begin to realize what 1 trillion stars actually looks like.